Hi, I'm Mr. Zapone, and my digits are significant. Are yours? So today we're going to look at the rules for significant figures. I know this excites you very, very much because you love significant figures. There are four very boring rules that we have to learn. They are important because we generally don't want to report answers or results that are more accurate than our least precise measurements. If you're only able to measure something to the tenth place, you should not be reporting a result that's accurate to the hundredth or the thousandth place. Your results cannot be any more accurate than the least accurate instrument you are using. So, significant figures are pretty important in laboratory settings. So let's just look at the rules. All non-zero numbers are always significant. And if we look at this number right here, well, all of these are non-zero numbers. So they must all be significant. So the number of sig figs is 5 per rule number 1. And again, all non-zero numbers are always significant. Well, even though there's a decimal here, we have 4 non-zero numbers. They must all be significant per rule number 1. In this one we have 900.06. Well, we know the 9 and the 6 must be significant per rule 1. The 9 and all non-zeros. And look at rule number 2. All zeros between non-zero numbers are always significant. So we have 3 zeros between two non-zero numbers. So these zeros are always significant. So we have 5 sig figs. So that's per rule 2. And let's look at this one. This one's a tricky one. 0.0004. We know the 4 is significant. All zeros between, that's not there. All zeros which are simultaneously to the right of a decimal point and at the end of a number are significant. That is not being satisfied. These are to the right of the decimal point, but they are not at the end of the number. And all zeros which are to the left of a decimal point and are in a number greater than or equal to 10 are always significant. These are not. There's only one zero to the left of the decimal point, and it is not in a number greater than 10. So the only significant digit here per rule 1 is this 4. So this actually has one significant digit. And one way to sometimes do a little check is to write the number in scientific notation. If you wanted to put that in scientific notation, you would have to move this decimal over 1, 2, 3, 4 places to the right. That would be 4 times 10 to the negative 4th. And you see there's only one digit here. If we wanted to put this one in scientific notation, we'd have to move this decimal over twice. 1, 2, and that would be 9.0006 times 10 to the second. And notice in scientific notation you have to have all 5 digits here because these zeros are placeholders. And you have 5 digits. So sometimes you can check your results by putting a number into scientific notation. There are a couple other rules we have to look at. So we know in this rule, hopefully by rule number 1, all non-zero numbers are always significant. So per rule 1, we at least have 2 significant digits. What about these zeros at the end of the number? All zeros which are simultaneously at the same time to the right of a decimal point and at the end of a number are significant. These 3 zeros are to the right of the decimal point and they are at the end of a number. So per rule 3, those zeros are significant. So every single one of these numbers is significant. So we have 5 significant digits here. And this kind of combines the other rules. We know the 5, the 1, and the 4 are significant. Why? Well, all non-zero numbers are always significant. We also know that all zeros between non-zero numbers are significant. So this zero is significant. This zero is significant. And that's rule 1 and 2. And what about this zero at the end? Well, all zeros which are simultaneously to the right of a decimal point and at the end are significant. This is to the right of the decimal point. It's at the end of a number. So that is significant per rule 3. So there are 6 significant digits in that. And one way to think of it is scientists are lazy. Let's look at this example here. If these 3 zeros weren't significant, we would write that as 8.1. Why are we going to go out of our way to add in 3 zeros? It's the same number. I mean, why not add in a million more if we're just going to write zeros for no reason whatsoever? So one way to think of it is if there's zeros after a decimal point, they're there for a reason. They're there because whoever's reporting that number, reporting that result, wants you to know that those digits are significant, that their device or instrument was able to measure to that level of precision. So that is why there's absolutely no reason to include this zero unless it is significant. So when we put in that number, it must be significant after a decimal. And what do we have here? Here we have 3 million. Well, all non-zero numbers are always significant. All zeros between non-zero numbers are significant. Well, we only have one non-zero number, so 2 doesn't apply. We know rule 1 applies to the 3. All zeros which are simultaneously to the right of a decimal point and at the end of a number are always significant. Well, these zeros are at the end of a number, but they are not to the right of a decimal point, so they do not satisfy rule 3. They do not satisfy rule 3. All zeros which are to the left of a written decimal point. We don't even got to keep reading this because there is no decimal point in this number. So none of these zeros are to the left of a decimal point. They cannot be significant. So this only has one significant figure per our rules. And if we wanted all these zeros to be significant, we'd have to put a decimal point right here. And that would make all these zeros significant, but we don't have one there, so they're not significant. And last but not least, we have 10.0. And remember, we would not include this 0.0 if we didn't have to. Scientists were lazy. We don't want to write numbers for no reason whatsoever. So if we are including this 0.0 there, that means we are telling you that we needed it. We are letting you know that our device was accurate to this level of precision. So hopefully you realize that there's going to be 3 sig figs here based on that. All non-zero numbers are significant. All zeros, this one doesn't apply. We don't have any zeros between non-zero numbers. There's only one non-zero numbers. All zeros which are to the right of a decimal point and at the end of a number are significant. This zero is at the end of the number and to the right. So per rule 3, this zero is significant, and per rule 1, the 1 was significant. And all zeros which are to the left of a written decimal point and are in a number greater than or equal to 10 are always significant. So this 0 is to the left of a decimal point. It is in a number that is greater than or equal to 10, so it is significant. So we have 3 rules. Just again, realize sometimes you can write a number in scientific notation. That will help you decide. And we're generally not going to write unneeded zeros or decimal points. If we don't put in a decimal point, that's because we don't need to. And if we do put in a decimal point, that is because we need to, because we are reporting that level of precision. So there's 4 rules, a little bit of a pain. You kind of got to get used to them. The best way is just do some practice problems to keep looking at these, but hopefully that helps you with significant digits, Mr. Sapone.